Now let's talk about an important point regarding the Poisson table. You may recall that in a previous video, we concluded that when we construct the probability distribution of a Poisson variable, right? So the probability distribution of a Poisson variable, the table essentially continues forever, right? So you may have 0, 1, 2, then we have 10, and then we have 1,000, and so on and so forth, right? And you have the corresponding probabilities for each of these numbers, right? So the table continues forever. So the natural question to ask is, for example, when the mean number of occurrences is 1.2, why does the table stop at 9? Okay. Here's the idea, the answer to that question, actually. Right? So the idea is as follows. When the mean number of occurrences is low, when the mean number of occurrences, which is mu, is low, it becomes less and less likely to observe larger and larger number of occurrences. Okay. Now this is actually very intuitive, right? For example, if you are an owner of a restaurant and you only expect 1.2 customers per hour, you wouldn't really see a group of 30 people come in very often, right? So it becomes less and less likely to observe larger and larger number of occurrences. So here, for practical purposes, we will conclude that the probability that x is equal to 10 is equal to 0, right? So especially when probabilities are rounded to 4 decimal places. Okay, and so the same thing applies to the probability that x is equal to 11. So when x is equal to 11, the probability of that happening is also 0 for practical purposes. And same thing for 12, same thing for 13, 14, and so on and so forth, right? 20, 30, 50, 100, and so on. So the idea is probabilities get smaller and smaller, right? But one thing you have to keep in mind is that probabilities will never actually be 0, right? But never equal 0. Okay? So it may get really, 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 really small, but it is never 0.